Testing empirically. When testing economic models, it's crucial to follow a structured approach to validate or challenge the relationships predicted by the theory. Let's walk through the steps. Step 1. Obtain data. The first step in testing any economic model is to gather data. For example, if we're testing the relationship between wages and employment, we would collect data on wages and employment rates across different countries or regions. This provides the foundation for analysis and helps us explore whether the model holds up in practice. Step 2. Graphical representation. Once we have the data, the next step is to visually plot the data on a graph. By doing this, we can quickly spot any trends or patterns. For instance, a downward-sloping line on the graph might suggest that, as wages increase, employment decreases, just as the model predicted. This graphical representation helps us understand the relationship between variables in a visual and accessible way. Step 3. Statistical analysis. Now, to test the relationship more rigorously, we move on to statistical analysis. One powerful tool for this is regression analysis, which allows us to quantify the strength of the relationship between variables, such as wages and employment. With regression, we can determine how strongly wages influence employment, and whether the correlation is positive or negative. Regression analysis. This technique provides a precise way of measuring the strength and direction of the relationship. By running a regression, we can assess how much change in employment is associated with a change in wages. This helps us understand whether the theory that higher wages might reduce employment holds true across different contexts, or whether other factors are at play. In conclusion, testing economic models involves gathering data, plotting it to visualize trends, and using statistical tools like regression analysis to confirm or challenge the relationships predicted by the model. This process ensures that economic theories are grounded in real-world evidence, making them more reliable for decision-making. Inductive models. Imagine we have data showing that as wages increase, unemployment rates tend to rise. From this, we infer that L equals 1 divided by W, meaning higher wages lead to lower labor demand. This is an example of inductive reasoning. While the data supports this conclusion, it doesn't prove it definitively. Inductive reasoning suggests that, based on observed patterns, the relationship is likely true, but not certain in every case. Other factors could influence the result, but the data suggests a strong trend. Criticism of mathematical economics. Mathematical economics, while useful in simplifying complex systems, is often criticized for its over-reliance on algebra. Many mathematical models are built on assumptions or axioms that may not accurately reflect the complexities of the real world. For instance, a model might assume that all workers are identical, but in reality, workers differ in skills, experience, and preferences. This simplification can limit the model's applicability to real-world scenarios. Another point of criticism is the difference between logical strength and realism. Mathematical arguments are logically strong as long as the rules of algebra are followed correctly. However, if the premises or assumptions of the model are flawed or unrealistic, the conclusions drawn from the model will also be misleading or false. In other words, while the mathematics may be correct in form, the conclusions may not hold true in practice if the initial assumptions are wrong. Thus, while mathematical models offer clear, logical insights, their assumptions must align closely with real-world conditions to be truly valuable. Testing empirically.